So I'm Fred Kim. I'm glad to see that you guys have joined and want to know more about what we do in VibeSys and more specifically in modal analysis. So this is the second webinar we do on modal analysis. Just for some of you who may have not attended the first one. The first one was last year in August. It was focused more on the fundamentals of structural dynamics and modal analysis. So you can still watch it in streaming from our website nCode.com. Now this one is we'll introduce again fairly quickly. Modal analysis, structural dynamics. It'll focus also on what's new in version 13 of the nCode products. So version 13 is out now. You can download it from our website again. And it'll also this webinar will also focus on how modal analysis, experimental modal analysis, can help the engineers involved with structural durability, as most of our users and customers, are in this area. So how is EMA useful to the engineer involved with structural durability? So allow me just to very quickly reintroduce VibeSys. So VibeSys is one of the software that part of the nCode suite of software. So we've got design life here for CAE-based fatigue analysis. We've got glyphs for general purpose and durability-oriented, I should say, signal processing. Automation, which is basically glyphs coupled with a database, Oracle-like, such as when you have loads and loads of test data, you may want to have a clear dashboard indicating, giving you an overview as opposed to being lost in the details. And we've got VibeSys. VibeSys is very similar to glyphs. For those of you who are familiar with glyphs and are glyphs users, if you have the frequency option in your palette, the frequency palette, well, this now is been renamed VibeSys, and I'll show you after this presentation how to access VibeSys. So the glyphs users we have online who have the frequency option have now VibeSys, and it's probably useful to mention the fact that if you are Prensia access users, in other words, this licensing with tokens, license unit system, well, you'll have access to VibeSys, just like you'll have access to all our desktop products. Also worth mentioning that within Prensia, we have also another branch that deals with reliability. So those are the ReliaSoft softwares that are very famous, like Weibel++, XFracas, FMEA, XFMEA, etc. So that's the ReliaSoft branch. So here we're focusing on nCode VibeSys. So a few features from VibeSys. VibeSys has capabilities for rotating machinery analysis. So in other words, waterfalls and extracting orders in time or frequency domain, displaying it with fancy color plots, color maps, or Campbell plots. So this is typically for diagnostics, understanding if anything goes wrong. It's also very used for proactive maintenance type applications on rotating machinery, so engines, turbines, gearboxes, pumps, everything. So there's been recently a webinar dedicated to rotating machinery. Just check out our website, and you'll discover the list of available webinars. Then we've got another area which is called the human perception. So that's for the human body. How does the human body react to vibration? So that's typically for vehicles, manufacturers, or tools like things that transmit vibrations to the human body. Or it's also to do with psychoacoustics. So acoustics, like how the sound is perceived. And it's all to do with comfort or discomfort, if you like. So either from vibration signals or sound pressure signals. We've got a new, in version 13, for those who are interested in this, we've got a new sound quality glyph with loudness, etc. So there'll probably be a webinar coming soon on this very specific subject. And what we're going to focus on for the next 15 minutes or so is structural dynamics. So everything's based on frequency response functions and modal analysis to understand the dynamics of a machine or a structure. So we'll focus on structural dynamics for now, right? But if I just end up talking VibeSys in general, we also have a vibration manager, which is very useful because it contains all sorts of typical vibration profiles that you can find in various standards, military or civil standards, and you can compare them. You can compare them with your measurements. You can add your own profiles, your own in-house qualification profiles or reference profiles. So that's a database of vibration spectra. And VibeSys has the same features and benefits as glyphworks. For those who are familiar with glyphworks, it's a matter of building an analysis graphically. So you in one glance you understand how what this process is doing in terms of analysis. So it's easy to construct, easy to use when you get a process sent by someone else. You understand, should understand pretty easily what your colleague did. And it's not limited in terms of the input data. We're very used to process time series data. We've got absolutely no problems with files that are over 1 or 2 or 10 gigabytes. It's got unlimited number of channels, sample rates, length. It's really meant. Since we're coming from the durability domain, fatigue domain, it's really meant for time series originally, right? Input. So we've got no problem with that. And we've got an awful lot of those glyphs, those little icons, each one doing something very specific in the area of signal processing. Here we'll just concentrate on a few of them, the one that computes the frequency response analysis, the one that does the experimental modal analysis, and the one that enables you to animate a structure. But we've got like over 100 of these, and if you don't find the exact algorithm you're looking for, you still can script your own algorithm there and lock it down and save it in the palettes. And the scripting language is either Python or MATLAB. So now let's focus on EMA, experimental modal analysis. So why would you want to do experimental modal analysis? Well, here's just a list that I gathered discussing around and reading books and papers and getting feedback from our customers. And it turns out that the main applications have to do with FE modeling, finite element modeling. So I guess that the first one is probably to validate an FE model. I guess we're all familiar with finite element analysis, numerical simulation. The beauty of it is you always get an answer. The question is how accurate, how realistic, how reliable is this answer? That's the main question, I guess. So running using the results of a test to correlate with the results from the simulation, numerical simulation is fundamental. And when it comes to dynamics, when a resonance or several resonances are excited, you need to do this correlation. And in particular, you want to compare the natural frequencies that your FE model has found versus what the natural frequencies that you've observed are doing your model tests. You want to make sure the mode shapes do also correspond. So that's basically to validate the modeling in terms of finite element modeling, right? And then when it comes to do some force response or dynamic analysis in FEA, whether in the time domain or frequency domain. At some point, you're asked to enter the damping ratios you want to use, and most of the time, people leave the default values or don't necessarily worry about those. So running an experimental model analysis enables you to extract this parameter from the tests and use it in your FE modeling to get accurate results. So it's extremely important to have those two bullet points right when you do FEA, and we'll illustrate that at the end of this presentation and with some examples. Then the classical historical reasons for doing experimental model analysis are listed below. So you want to troubleshoot for noise and vibration problems, how come it's so noisy or so vibrating. So you want to compare basically the natural frequency of your structure with the range of frequencies